Hello friends, I thought I'd upload a video showing how I tackle this problem. Who knows, maybe you'll learn something. So, let's start off with the mass spectrum here, and I'm just going to identify a couple peaks. So we've got our base peak at 43 m over z, not sure what that is yet, and then we have our m plus peak at 86 m over z. So that means our molecule weighs 86 grams per mole. 86 gmol. Cool. So that's all the information I kind of want to get for now. And we can go down to here and see what it's likely to be at 43. And it's going to be CH7 or C. So I actually just copy and paste that so I can have that for later. Cool. That means those things. We can't tell yet. Okay, that's all the information I want to get out of that. Now here, we can go down to our IR spectra, and we can see what's happening at the 3000, and I see some CH peaks, some CH stretches. So straight away, this, to me, that's a CH stretch. So it's got CH bonds in the molecule. Stretch at 3000 centimeter negative 1. Cool. And we could even say that's sharp, because it's quite pointy. Here, this is a very common peak at about 1720, so we can say about 1700 centimeter negative 1. We've got a sharp, strong stretch, which indicates a carbon-oxygen double bond. Okay. That's about all the information I can get out of this. Let's move on to our NMR. Here we go, NMR. 4 peaks, 4 carbon environments. We've got a one at 220 ppm, which is the CO bond, carbon-oxygen, which is this carbon on the carbon-oxygen double bond, because it's less shielded. And then we've got 3 which are kind of shielded over here. So if we go down to our data sheet, we go to here, and by looking at the 220, I'm saying this is likely to be a ketone. Okay? It is likely to be a ketone. So, likely to be ketone. Now I've got a functional group in mind. I'm going to open up my MS Paint, and we can start drawing it. So I know that, and the ketone has carbons coming off it. Okay, that is what I've got so far. Not much, but 3 carbons and an oxygen together weighs, that's 36, and then that's 52. That weighs 52, and of course that's only 2 carbon environments. So 1, 2, 3. If I add another carbon here, CH3, and these are obviously, there were H's on these as well, that has now bumped it up to 4 carbon environments, okay? Which is how many carbon environments we've got in our NMR spectra. By adding in all these hydrogens as well, that's 3, that's 5, that bumps it up to 72, our mass. Okay, our mass for this molecule is now 72, which is not big enough for that. If we add another CH3 onto here, that increases our mass by 15. We get rid of this hydrogen, which goes down to 14. And that gets our mass up to 88. Okay? This mass of the molecule is now 88. And we can check if that's right. So I've just done this in my head. I'm not actually sure this is the correct answer or not. But these 2 carbon environments are the same. It's a really badly drawn picture, by the way. Hopefully you can draw a lot easier than I can. These two are the same, so that's 1 carbon environment, 2 carbon environments, 3 carbon environments, 4 carbon environments. This CH3 is actually a different carbon environment to this one, because this CH3 is bonding to a carbon which is bonding to this double bonded oxygen, or these CH3s are bonding to a carbon which is bonding to another carbon and hydrogen. So there has to be some sort of symmetry for them to be the same carbon environment. So we've got 1 here, 2, 3, 4. Notice the peak here is double the height of all the others, meaning that peak there is likely to be this one here. Okay? How do we check this now? How do we check if this is right? Well, we can go to our fragments here, and could we get C3H7? Well, imagine the molecule split here. This molecule split and it became this. Okay? This is C3H7. This is also CH3CO. So the reason why this base peak is so high is because I think the molecules split down the middle here, and these two fragments, both weighing 43 each, are being detected here. So I think it's not or, it's both. Because both of these fragments will be detected if the molecule split down here. What else can we see? What are the big peaks? We got this one at 27. See if we got a 27 peak here. At 20, is that 27 or 28? 27. What could that be? CH3 and a carbon, maybe? It's an odd one. Okay. So I'm pretty sure that this, with a bond there, is our structure. I could be wrong, but we look for evidence and we fit the evidence to what we see. Alright, so this matches up our NMR. We just need to identify this one and maybe this one. Matches up with our IR for this one and this one. And it matches up with this base peak, this top peak, and let's see what the 71 is. This 71 is our 86 minus 15. So 86 minus 15 is 71. So this is our molecule losing a CH3. And probably loses this one. Or it could lose one of these ones. We don't know. But it will lose a CH3, and that will be detected. Alright, thanks guys for watching, and I will see you tomorrow.